Hi everyone, so today again I'm back with another tutorial on calculus integration. So I'll just continue from where we ended. So today I'm starting with question 5, and just by looking at these questions you can agree with me that most of these questions can only be solved by using integration by parts. And then the formula for integration by parts is this one here. So in short, from what we have been given here, you have to choose which one is your u, which one is your dv. And the way you choose this, the way you choose, you follow this word here, which is Liat. Which means logarithms, inverse trigonometric, and then this is algebra. Then this one is trigonometry, and then the last one you choose the exponents or exponentials. So yeah, we can begin. So I'll solve these questions very quickly because they are all straightforward here. So when you look at this first question here, algebra is coming earlier than exponentials. So what you do, you choose your x as your u. So my u here from that question, my u is going to be x, and then my dv is going to be equal to e to the power x, and then dx. So from from what we've been given here, we can now use the formula. So this formula, it says the integral of x. So my u there is x. So the integral of x, e raised to power x with respect to x is just equal to, so this one is just equal to, you can see here we're saying u v. So I already have my u here is just x. My u is x, but I don't have v. So I'm going to get v from dv dx. So my dv, when I divide this expression here by dx dx, I'm going to have d. Anyway, in fact, I'm not even supposed to do that. What I'm just supposed to do to find v, because I know that this is dv dx. Anyway, let me just show you the whole process. So when I divide everything there, I'm going to have dv dx being equal to e raised to power x, like that. So from just this expression here, we can get our v. So when you integrate this and then integrate also this part, we're going to have, when you integrate dv with respect to x, or when you integrate dv, or the simplest way of saying this, let me just show you this way so that you don't get lost. So it's going to be like this. I'll just get this same part here, dv being equal to e raised to power x, and then dx. So I'm going to introduce the integral signs. So when I integrate this with respect to v, I'm going to have a v, because I'm integrating 1 with respect to v. So I'm going to have v being equal to, when I integrate this e to the power x with respect to dx, with respect to x, I'm going to have the same e to the power x. This one does not change. So in short, my v is just going to be equal to ex. So where there is v, I'm going to put e to the power x, and then minus the integral of v. Which one is v now? V is e to the power x, and then du. Which one is du now? So you get du by differentiating this. So when you differentiate this expression with respect to x, you're going to have du dx being equal to, when you integrate x there, this x, you get 1. So once you do that, you can cross multiply to have your du being equal to dx. So meaning where there is a du here, I can put dx. So I'm integrating e to the power x with respect to x. So this one will now finish like this: x e to the power x minus the integral of e to the power x with respect to x. I'm going to get the same e to the power x. Of course, don't forget to put your constant c. So this is your first integration there. This is your first solution for the first question here. Yeah, that's the solution for the first question. Yeah. So we move on to the next question. So let us skip this one, which is x e to the power x minus e to the power x, because it may be useful on the second question here. So okay, let me just so I'm keeping that e, it was like this: x e to the power x minus e to the power x, like that, plus c. I'm keeping this for the sake of this question here. So again, this question, we're following the same procedure, Liad, following this same mnemonic word to choose which one is our u. So our u, according to this algebra, is coming first than exponential. So I'm going to get my u being equal to x to the power 2. So meaning my du will just be equal to 2x dx. That is my du. And then meaning my, so from this expression, it means that my dv is just equal to e to the power x dx. That is my dv. So from there we can find v by integrating both sides. So when you integrate both sides, we're going to have v being equal to e to the power x. Yeah, so we can now use our formula there. So I'm saying the integral of x squared then e to the power x dx is equal to uv, meaning my u there is x squared, then my v is e to the power x, then I'll say minus the integral of v, my v is e to the power x, then du is just this part there, which is so I'm multiplying this by 2x 2x dx. So we can see that this expression can also be written in other form as let me just write it well. So it can also be written as two outside, and then we have x e to the power x dx. So we can also write it in this form. So you can see that the integral of x to the x times e to the power x is just what we found here. So this is the reason why I said we keep this. So where there is this part, I'm just going to replace with that. So my solution will now be equal to e to the power x minus 2 and then open bracket x e to the power x minus e to the power x, and then close the brackets plus c. So here is just a matter of simplifying the expression. We have e to the power e x minus, and then 2x ex minus 2e x plus c. So this is the solution for this question here. So even this one you do the same, even this one you're going to do the same. You make your u being equal to x and then you differentiate that, you get your solution. So let's do this one. We also do this one, and this one or that one will be choosing. So I'm moving to this one. So for this question here, this one can also be written as the integral of 1 and then ln x dx. So it's going to be like this now. So you when choosing that, using this layout, using this, so when choosing, the way you do this is you choose your ln x, because ln is the one that is actually the first one there, which is logarithms. So you choose your ln as your u. So I'll say my u is equal to ln x. Then the remaining expression is the one that I'm taking as my dv. So my dv is equal to 1 dx. So here u is equal to ln x. So to find du dx, to find your du is just going to be equal to 1 over x dx. When you differentiate ln x, you get 1 over x. And then when you find the derivative of dv, when you integrate dv, when you integrate this part with respect to v, you are going to get v. And then this side, when you integrate 1 with respect to x, you get x. So here you discover that your solution will now be equal to, your solution is going to be the integral of ln x dx will now be equal to uv. So your u will be ln x and then your v is x. So in short, we're going to have x ln x. So we'll now have x ln x minus x ln x minus the integral of v, which is x, and then du is 1 over x dx. So here it's just a matter of simplifying the expression. X ln x minus this x and that x will cancel, so you just remain with the integral of 1, which gives you x. Then don't forget to put your c, because these are indefinite integrals. So this is how you solve such questions. They are just as simple as this. So again, I'm going to keep this to solve this question here. I'm going to keep x ln x ln x minus x plus c. I'll keep this solution here. So sorry, x ln x minus x, then plus c. So we proceed now. We're going to, so for this question again, ln is always first in this. So ln logarithms are always coming first. So here you get your u to be equal to ln x, and then your dv is going to be equal to x dx, meaning your v, when you integrate that, you get your v to be equal to x squared over 2. And then here when you differentiate that, you get your du being equal to 1 over x dx. So here is now just a matter of plugging your information into the formula there. So when you so you're going to have something like this: x ln x dx. X ln x dx will now just be equal to, so uv, so it's going to be x squared over 2, and then x squared over 2 uv, it's going to be x squared over 2 ln x, and then minus the integral of my v is x squared, so I can write it as 1 over 2 outside, and then x squared there, and then my du is 1 over x dx. So when you multiply the two, you discover that you're just going to remain with x, because 1x down there will cancel with 1x on top. So you're going to have this, and then when you integrate this, you get your answer to be x squared over 2 ln x, then minus, then integrate this, is going to be 1 over 4 x squared. Then don't forget to put your c. So this is how simple these questions are. Let's proceed to the next question. So the next question again is straightforward. So I think instead of me solving this one, since this one is more simpler than this one, I'll solve this one, and then because this one is a little bit complicated than this one. So yeah, but the problem again is that I need this one for me to solve this one. So okay, let me just solve this very quickly. So from Liet you can see that algebra is coming faster, or is coming earlier than the trigonometry. So meaning my u is going to be equal to x, meaning du will just be equal to dx, and then my dv is equal to sine x, and then yeah, dv is equal to sine x dx. So v is now going to be equal to, when you integrate dv with respect, when you integrate 1 with respect to v, you get v. When you integrate sine x with respect to x, you get negative cos x. Yeah. So here's just now the matter of putting the my solutions into to the expression there. So I'm going to have the integral of x sine x with respect to x being equal to, my u is x, my v is negative cos x, minus the integral of my v is negative cos x, so my v will be negative cos x, so I'll just do this, and then my du is just the same as dx, so when you integrate this you'll get negative cos x, negative x cos x, and then when you integrate cos x you get sine x, so plus sine x. Yeah, so this is your solution. I guess just from seeing how I've solved this, you can also solve this one. So for this one, your u will still be equal to x squared, and then you differentiate that to find du, and then your dv is going to be sine x dx. When you integrate when you integrate sine x with respect to x, you are going to get cos x. Yeah, you're going to get negative cos x. Okay, so let's proceed. So on this question here, this question is a little bit long when it comes to integration. So what they've decided to do is to just make up to it's just to make the general formula in short. So if you want, you can integrate it by choosing your u as e to the power x. Let's check. Yeah, so your u there is actually cos x. Sorry, your u there is going to be equal to this e to the power x, and then your dv is going to be that part. So once you do that, you can use this formula there to, or if you want, you can just use this formula here, which is straightforward. You just plug in the values there. You can see that a is just the number that is there, then b is just the number that is there, and in this case our a and our b are just O1s, which implies that when you plug them in there, you're just going to have e to the power x on top there, and then everything divided by 1 squared plus another 1 squared, and then your b there is 1, so it's just the same as writing sine bx, and then your a there is still 1, so it's just the same as writing cos bx. Sorry, not bx, my b is also 1, so it's just the same as just putting cos x sine x, and then you close the brackets like that. So you simplify this by writing 1 over 2 e to the power x, and then you write sine x, put them in brackets of course, then plus cos x. So you have integrated the expression. As simple as that. Yeah, so same applies when you have sine x here. When you have sine x there, you just use this one here. Just switch these, you just switch a and b and then put a minus there while there was a plus in cos. So that's how you integrate these. Yeah, just as simple as that. Let's see how you integrate this one. This one you can either use integration by parts or substitution. How do you use substitution? Revision. Let us just revise on how to use substitution. So you choose one of the two functions to be used. So in my case, I'm going to choose my u to be equal to sine x. So when I find du from sine x, du is just going to be equal to cos x dx, which implies that if I'm if I'm to make dx subject, then I'm going to have 1 over cos x du. So where there is sine x, I'm going to replace with u. Then where there is cos, and then when there is dx, I'm going to put this part 1 over cos x du. So I start where there is sine x, I'm going to put u. Then where there is of course from this question I forgot to put a c. After replacing your a and your b there, you put c at the end, a constant. Then where there is let me write that cos theta there, I mean cos x. While there is dx, I'm going to put 1 over, so I'm going to put 1 over cos x, then du this side. You can see that that and that will cancel, so meaning I'm just remaining with the integral of u with respect to u. So when you integrate that, you are going to have u squared over 2 plus c. Then when you when you replace u now with sine x, it means that I'm going to have sine squared x. I'm going to have sine squared x over 2 plus c. So this is the solution for this question as well. Yeah, so it's as simple as that. If you want, you can use integration by parts, you still get the same answer. So let's proceed now to this question. So for this question here, you can see that from Liet, our u is going to be equal to the inverse, because the inverse trigonometric is coming first than it's coming first and not the algebra. So meaning my u here is just going to be equal to sine inverse of x. So meaning if I'm to find my du there, du will just be equal to 1 over the root of 1 minus x squared. So this is the derivative of sine inverse of x. Sorry, this is supposed to be dx, sorry. It's going to be like this. So this is how you differentiate an inverse trig function. Yeah, so if you want to see where I got this, go and check John Bay. They are all there. You find sine inverse, cos inverse, tan inverse. You also find shin. You also find cosh. Yeah, you find them in John Bed. So apart from this, now we can now use our formula. Oh, sorry, our dv will now be equal to. Sorry, our dv will now be equal to x dx. So when you integrate both sides like that, you're going to have your v being equal to x squared over 2. Yeah, you're going to have x squared over 2 plus c. Oh, sorry, in this case, yeah, we're not going to add c. X squared over 2 plus c. And then we proceed. So this is going to be your integral, meaning this is going to be your v. Then we just add them in that equation now. So we're going to say the integral of that, the integral of x sine inverse of x with respect to x will now just be equal to uv. So my u will just be sine inverse. So in short, I'm going to have x, this is my v, then my u is just sine inverse of x, then minus the integral of my v is x squared. So since there is this 2 there, I can write it outside there, 1 over 2, and then I'm going to have x squared being multiplied by my du there, this du being multiplied by everything here, which will just give me the root of 1 minus x squared dx. So from this, I'm pretty sure now we can all solve this, because you can see that the integral of this can just be written as, you just make you can use the change of variables to integrate this part. So I'm going to have your u being equal to 1 minus x squared, meaning x squared will just be equal to, so x squared will just be equal to 1 minus u. Yeah, so this is your x squared. So in short, while there's x squared here, you can put 1 minus u, and then denominator here will just be the root of u, and then while there's the dx, you find du dx from this one. So du dx from this expression here, we are going to have negative 2x. So meaning my dx is going to be equal to 1 over 2x. It's going to be equal to negative 1 over 2x du, like that. So it's just a matter of just replacing it there. So we'll put negative 1 over 2x, and then you have your du there. But remember, while there's x there, you can make x the subject. You can make x the subject from this, meaning your x will just be equal to the square root of 1 minus u. Yeah, so you can put your 1 minus u there where there's x. Okay, this is sine inverse of x. Yeah, so from there you can now put, where there's x, you put the root of that. So then when you multiply, so you have something like this. Just trying to simplify it to a point where everyone can manage to solve it. Minus 1 over 2, then you put the root of 1 minus x squared there, or 1 minus u to the, and then the root of 1 minus u there. So and then you multiply this 2 times that 2, then this negative times that negative, meaning you have a plus here, and then this 2 times 2 you get 4, and then here you're going to have the integral of 1 minus u on top, then over the root of u times 1 times x, which is the root of 1 minus u, is just the same as u minus u squared. Yeah, so from here you guys, I'm sure you can all simplify this. I mean, you can all integrate this. Yeah, you can all integrate this. So let's move on to the next question. Let's move on to the next question. We'll see what's there. Okay, this is question 6. So question 6 is saying show that the integral of this is equal to that. So in short here, this is a definite integral. What we've been dealing with so far were indefinite integrals. This one is a definite integral. So to show that, we're going to integrate this and also take the limits of that. Taking these limits here, from 1 to 0 or from 0 to 1. So we can integrate this by using change of variables. How do we do that? I'm going to say let my x be equal to, my u, let my u be equal to x plus 1. So meaning x will just be equal to u minus 1. So in other ways, I can write my integral as this. So this is going to be equal to u minus 1 on top, and then everything divided by the root of u. And then on dx there, I will differentiate this. So meaning my dx is just going to be equal to du. So meaning what this dx, I can also replace that part with du. So this is what we're going to integrate now. So when you integrate this, this is going to give us, or in other ways we can write it as this, u minus 1 in brackets, and then multiplied by u to the power half. Of course this half will now be negative, du. So this is just going to be equal to, we can simplify it further by saying this u to the power negative half times u to the power 1. So meaning when you add the powers there, you get a positive u. Don't forget to put your limits. You get your u you get your u to the power half, and then minus this 1 times u to the power negative half, you get u to the power negative half. And then we're integrating that with respect to u, not x. So when you integrate this, you're going to get something like this. Integrate that, this first part here, you get u to the power, half plus 1, you get 3 over 2, and then everything divided by the new power, which is 3 over 2. And then you get your minus. You integrate this negative half plus 1, you get positive half, which is just the same as u to the power positive half. Then divide by the new power. The new power is half. So this is going to be your new power, and then you close your brackets, and then don't forget to put your limits like that. So here what we're now going to do is we simplify the expression there inside. So that expression can also be written as 2 over 3 root u to the power 3, and then minus you have 2 root u, and then you write your limits 1, 0. So this can also, let me just do this. Okay, so this can also be written as, now we replace where there is u with x plus 1. So this can be written now as 2 over 3. Then where there is u, we put x plus 1. raised to power 3, and then minus 2 the root of x plus 1, and then we close the brackets like that. So I'm going to have 1 there, and you get your 0 there. So here it says now the matter of inserting our limits. So we first start by inserting 1. So while there is x, we put 1. So when we put 1 while there is x here, we're going to have 2 over 3, and then 1 plus 1, it will be 2. So the square root of 2 to the power 3 is just nothing but 2 root 3. Okay, you are going to get you are going to get the square root of 8 in short, which is just the same as 2 root 2, sorry, not root 3, 2 root 2, and then you get minus, you put 1 there, you're going to get 2 root 2. Yeah, so after doing that, you also now move on to, after putting 1 where there's x, we now put 0 where there's x. So when we put 0, we're going to have 2 over 3 there, then minus 2, because when you put 0 there, you're going to have 0 plus 1, which is 1. The root of 1 is 1. 1 times 2, you still get 2. So we just have to simplify this. Then we are done with the question. So this is going to be 4 over 3. 4 over 3 root 2 minus 2 root 2, and then this is going to be minus. When we simplify what's in the brackets this side, we're going to have this is 2 minus 6, which is negative 4. 2 minus 6 will be negative 4. So we're going to have negative 4 over 3. So when we have negative 4 over 3 there, it's just the same as opening the brackets and putting a plus there. Since we had negative 4 over 3 in the bracket, so you just put a plus there. And then here what we do now is just a matter of it's just a matter of, okay, let's see what we can do here. We can also find the common denominator there, which is just going to be 3. Then 3 into 3, so you get 4 root 2 there. Then this will be 3 times 2 there, you get 6 root 2. Then there you get 4. So this can also be simplified to, when you add 4 minus 6, when you subtract there, you get negative 2 root 2. Then you have plus 4 this side, then everything over 3. So when we factor out 2 over 3, since we want to leave it in this form, means that we have to factor out 2 over 3. So when we factor out 2 over 3, we can have something like this. Then open brackets, I'll start with a positive number. When I factor out 2 from 4, I'm going to remain with 2. And then when I factor out 2 from negative 2, I'm going to remain with negative, and from negative 2 root 2, I'm going to remain with negative root 2, like that. So we are done with this question. You even write down there, hence shown, since I wanted you to show. So just write down, hence shown. Okay. Then you are done with that question. Let's proceed and check if there are other questions that we can solve for today. Alright, So these are also definite integrals. So for a definite integral, since we have done these other questions, I'll just show you how you go about with any definite integral. And when you look at most of the questions that are here, we've solved them already, such that we are solving them using indefinite integrals. So from the indefinite integrals that we are solving, you're just going to be putting in the limits now. So I'm just going to start putting in the limits. So in short, I'm just going to solve this one, probably even this one. Yeah. Okay, let's see. Yeah, we can solve this one, and maybe this one. After solving that, and then we'll count it done for today. Yeah, let me see question 8. Yeah, I'll count it done for today, so that the next time I'm going to make the video, I'm just going to make it on finding the areas enclosed by given curves or by given lines. Yeah, and then you also find the volumes according to the questions. So next time we meet, I'm going to show you volumes and areas, but for today, let's just end on this question. So I'll show you how to solve definite integrals on this one. So for definite integrals, what you need to understand is that you always have to be given the limits. So you first just differentiate your expression in the normal way that you always differentiate it. The normal way meaning the way in which we were differentiating them, in indefinite integrals. So this is your question, dx, and then here you have 2 and 1 as your limits. So when you integrate these, you're going to have that. If you want, you can put your limits this side, or you can put them after. I like putting them after. So 5x, you add 1 to 4 there, you get 5. Yeah, so when you add 1 to 4, you get 5. Here you also get 5. You also get 5. Then you close like that. You put your limits 2 and 1. So how do you distribute your limits? You first start with this one on top. Let me just simplify this. You can see that this 5 and that 5 can cancel. So meaning I'm just going to have x to the power 5, then over, yeah, there's nothing like even putting the over there. So just put the limits. The limits are 2 and 1. So where there is x, you just put 2, and then subtract. Where there is x, you put 1. So where there is x, I'm going to put 2, so it will be 2 to the power 5 minus, so I'll put this in brackets, minus, where there is x, I'm going to put 1 to the power 5. Then we all know to say 2 to the power 5 is nothing but 32 minus 1. So this will give you 31. So this is your solution for the first question. Let's proceed to the next question. After solving the next question there, I'm pretty sure I can now solve. I'm going to solve, yeah, this one, and then by that time I'm sure you would have known how to solve integrals. So we proceed. Let's start. So this one here, just by looking here, you can simplify it. Instead of writing it in that form, you can write it in this form. You say x times x there, you get x squared. On this question here, x squared, and then you say minus x times 1, you get x, and then you write it like that, dx. So you can integrate this, and then after integrating, you get x to the power 3. So you get x to the power 3 over 3 minus x squared over 2. And then don't forget to put your limits. So being limited just from 0 to 1. So we start by plugging in 1 where there's x. So in short, we're going to have 1 over 3 minus 1 over 2, because 1 to the power 3 you still get 1. 1 to the power 2 you still get 1 over 2. And then you put these in brackets. Then you say minus, you get 0 to the power 3, you get 0. Then over 3 minus 0 to the power 2, you get 0. Then over 2, like that. So this you get when you simplify this expression there, you get something like negative 1 over 6 as your solution. And then you know that when you subtract these, you still get 0. So meaning the final solution there, you just have negative 1 over 6 as your solution, as your answer. So this is going to be your answer for this question. Let's proceed and do the last question for today. So I'm going to do this one as my last question, because the reason why I've skipped some of these questions, we have already solved this using indefinite integrals, meaning from the solutions that we've had, so that we solved, you just need now to put in the given the given limits there. And then for this one, let me just say something before I go to this one. For this one, you can see there is e there as our upper limit, and then our lower limit there is just 1. So while there is x, you put, so after integrating, where there is x, you come and put e on the upper limits, and then on the lower limit you put 1. And you know by now to say the ln of e is nothing but 1. And then you also know that the ln of 1 is just 0. So that's what you need to know on this one. Then on the remaining questions here, you can see angles are not difficult to deal with. Yeah, so let us also do this one. So on this one, for me to solve this properly, I'm going to use substitution. And how am I going to do that? I'm going to say let this sine x here to be equal to u. Let sine x be equal to u. So here now I'm just going to find du dx. So my du dx there will now just be equal to, so my du dx will be equal to, my du dx there will just be equal to cos x. And then if I'm to write this in terms of u, I'm going to have the integral of e to the power u, and then cos x. And then while there's dx, I'm going to replace with, I'll make dx the subject in this expression here. So when I make dx the subject, I'm going to have my dx being equal to du over cos x. This is going to be my dx. So now here's just the matter of replacing there. So I'm going to have my du there, and then everything divided by cos x. You can see that and that are cancelling, so meaning I'll just remain with the integral of e to the power u times du. And then so when you integrate that, don't forget to put your limits, by the way. So when you convert pi to the power 2, or pi over 2 into degrees, that is just a 90. So you can just put a 90 there, and then you put your 0 there. So integrating e to the power u with respect to u will still give you e to the power u. So we have our upper limit being equal to 90, lower limit being equal to 0. So the integral of that, you just give you e to the power u, and don't forget to put your your limits there. So you can either use your limits in radians or in degrees, you still get the same marks. Then you can see that this u is not u. The limits here were supposed to plug in where there's x and not where there's u. Hence you change your u now. You recall that your u was just equal to sine x. So in short, what we have here is not e to the power u, but e to the power sine x. And then you put them in brackets like that. And then your upper limit there is 90, your lower limit there is 0. So here's just a matter of replacing where there's x we put 90, where there's x we put 0. So we're going to have e raised to power sine 90 degrees, and then you write it in this way, then minus, you get again e raised to power sine 0. E raised to power sine 0. Then so you're going to have, we all know to say sine 90 is just 1. So this is just the same as e to the power 1. E raised to power 1 is just the same as e. Then minus, we know to say sine 0 is just 0. So this is just the same as having e raised to power 0. Then your final solution will now just be equal to e minus any number raised to power 0 is 1. So your final solution for that integral is e minus 1. Yeah, so thank you very much for watching the video. Yeah, it's just unfortunate that where I am, there are a lot of network challenges, so I'm unable to be conducting Zoom meetings, but I'll just be giving you guys these videos, and I hope that you are understanding. Where you have questions, where you are stuck, I've given you freedom to be asking questions anytime, yeah, I'll be there to respond to you. So thank you very much for watching. Feel free to ask questions.